Hello guys, welcome back to my YouTube channel, and for today's video, we're going to tackle about the Chapter 5, a packet tracer in the NetAcad, so which entitled Examine the ARP table. So here in our guide or instructions, it, we are given the addressing table, so later on we will going to refer to that table, but first let's read the objectives of these activities. So first is examine an ARP request. The next is examine a switch MAC address table. And then examine the ARP process in remote communication. So the background on this activity is optimized for viewing PDUs. The device is already configured. You will gather PDU information in simulation mode and answer a series of questions about the data you collect. So part 1, examine an ARP request. Step 1 is generate ARP request by pinging 172.16.31.3 from 172.16.31.2. So first, we need to click the desktop PC which have the IP address 172.16.31.2. So this is it. Then go to command prompt. Then we're going to enter the ARP-D. Oh, I'm sorry, mistype. ARP-T. So that command will clear the ARP table. So next is we enter simulation mode and enter the command simulation mode, and then we're going to uh, enter the command ping, then going to ping 172.16.31.3. So while waiting for the reply, so PDUs will be generated. The ping command cannot complete the ICM packet without knowing the MAC address of the destination. So the computer sent an ARP broadcast frame to find the build-up MAC destination. So as you can see here, so this is the ISCP that cannot be completed. So without knowing the MAC address of the destination. So the computer sends an ARP broadcast frame to find the MAC address to the destination. So we're going to click the capture forward once. So it is here. And as you can see, the ARP here is gone and it is going to switch. So what is the so then how many copies of PDU did the switch and we're going to click again. So how many copies of the PDU did the switch one make? So as you can see in the simulation mode earlier, it sends a 3 ARP, rather PDU. The next is, what is the IP address of the device that accepted the PDU? So as you can see here, router 1 and the desktop that has the IP address 172.16.31.4 did not receive the PDU, but the ones that received the PDU is this PC, which 172.16.31.3. So open the PDU and examine layer 2. What happened to the source and destination MAC addresses? So we're going to click here. Here you will notice that the source became the destination and turned into MAC address of 172.172.16 dot 31.3. So here earlier our source MAC address became the destination MAC address. So next is click the capture forward until the PDUs return to 172. So we're going to click again the capture forward until it reaches to 172. So how many copies of the PDU did the switch make during the ARP reply? So as you can see here, it only managed to make this one ARP reply. Next is to step 2 is we need to examine the ARP table. Note that the ICMP packet appears. Open the PDU, open the PDU and examine the MAC addresses. Do the MAC addresses of the source and destination align with their IP address? So when to open the PDU, the MAC address here is here and here. Here the MAC address, source MAC address. This is the target MAC address. So do the MAC address of the source and destination align with their IP address? So yes, it aligns. So next is switch back to the real time. So we're going back to real time and the ping completes. So click the 172.16.31.2 and enter the ARPA command. So click here 172.16. Then we're going to enter the ARP command. The next is now that we enter the command the ARPA here. So to what IP address does the MAC address correspond? So the MAC address entry correspond is to 172.16.3. So this is the IP address that corresponds. So the 172.16.31.3. So next is, so in general, when does an end device is issued an ARP address? So when it does not know the receiver's MAC address. So part 2, examine a switch MAC address table. So step 1, generate additional traffic to populate the switch MAC address table. So from 172.16.31.2, enter the ping command 172.16.31.4. Sure, we're going here again and we're going to ping the command ping the IP address 172.16.31. And after that, click the 10.10.10.10.2 and open the command prompt. We're going to desktop tab and then command prompt. Here we're going to enter ping 10.10.10.3. So here are the replies. So the question here is how many replies were sent and received. So as you can see here, there are 4 replies sent and 4 replies received. So step 2 is to examine the MAC address table on the switches. So click the switch 1, switch 1, then CLA tab, and then enter. We're going to enter here the show MAC address table command, and here. Then once we show the the MAC address table, the question here is, do the entries correspond to those in the table above? So let's check here in the table. This is 002 0164, so this is it. Then 00C, 00C, so here is it. Then 006, this is it. And then the 00E7, then this is it. So now that we assure that all of the MAC address is present here in our table. So next thing that we have to do is to why are there two MAC addresses associated with one port? So because both devices cannot both devices connect to one port through the access point. So part 3, examine the ARP process in remote communication. So step 1, generate traffic to produce ARP traffic. So click the 172.16.31.2. We're going here again, and then click the command prompt, and we're going to ping 10.10.10.1 command, and then type the ARP slash A. So what is the IP address of the new ARP table entry? So as you can see here, the new ARP IP address is this, the 172.16.31.1. So next is enter the ARPD to clear the table. /t clear the table, and then switch to simulation mode again, and repeat ping sorry what I'm going to do here is to repeat ping. We're going just to repeat the ping of the 10 ping 10 what's that one, what's click capture forward. So next is we're going to click the capture forward, then the ARP send to switch. Then question here is what is the target destination IP address of the ARP request? So the target ARP request should be in the 172.16.31.1. Then next is the destination IP address is not 10.10.10.10.1. Why? Why is that? Because the gateway address of the router interface is stored in the IPv4 configuration of the host. If the receiving host is not on the same network, the source uses the ARP process to determine a MAC address for the router interface serving as the gateway. Next, step 2 is examine the ARP table on router 1. So we're going to switch again to real-time mode and click the router 1 and the CLI tab. And what we're going to do here is enter in a privilege exec mode, and then we're going to type the show MAC table again. So how many MAC address are in the table? So 0. So we have a 0 MAC address here because this command means something completely different than the switch command show MAC address table. So next is to enter the exec privilege mode and show the MAC address. Then enter show ARP command. Is there an entry for 172.16.31.2? Here. So intranet. So 17 is there's an entry for 172. So yes, there is an entry. Then what happens to the first ping in situation where the router responds to ARP request? So obviously what will happen here should the ARP request will be it times out. So that's it for today's video. So we managed to examine the ARP request, examine the switch MAC address table, examine the ARP process remote communications. If you like this video and if you learned something, press the like button and subscribe to my channel, and thank you for watching. Bye bye.